All right, thank you so much for joining us today. So we are done with first order differential equation and we want to look at second order differential equation. So second order because we have the order to be 2 because we are differentiating the function twice. And with the second order differential equation, we are going to look at two things here. We are going to look at homogeneous second order and non-homogeneous second order. In this video, we are going to talk about homogeneous second order. Before, when we are done, we talk about non-homogeneous second order. Now, the differential equation, this differential equation is homogeneous when we have a prime prime plus b prime plus cy to be equal to 0. So when we take the left side and we equate it to 0, then we have the what? The homogeneous second order. And then the function this itself, it's the non-homogeneous. So we have y prime prime by prime plus cy is equal to gen of x. And this becomes the what? The non-homogeneous because it's not equal to 0. Right. Now let's talk about initial condition before we start. Now, when we are talking about first order, we talk about initial condition. Now here, we can see that the order is 2. So it means that the initial condition 2 is coming to change. As we saw from the first order, because it was first order, let me say ay prime plus c is equal to 0. We had the initial condition to be, let's say, y of x naught to be equal to a naught because it is just the first order. So the initial condition given to us for us to move from general solution to particular solution is just 1. Now, since this has 2 order, then it means that we need to have 2 initial condition. So the first initial condition will be the same as the initial condition given to us in the first order. The other one is going to be y prime of x naught is equal to, let me say, b naught. So this here, we saw that this implies that y is equal to a naught and x is equal to x naught. Now this implies that y prime is equal to b naught and x is also equal to x naught again. So that is the only difference that we are going, or the things, this is the only thing that we are going to see which is differently from the previous initial condition that we learned. So we are going to have 2 of them before we can convert from particular solution, or we can move from particular solution to a from a general solution to a particular solution. Now let's talk about homogeneous, right? So we want to talk about homogeneous second order, as I said. And with the homogeneous second order, we said the first coefficient here should not be 0 because as soon as this one is 0, it moves towards the linear differential equation, right? And we are saying that this is constant coefficients because we are assuming that this, and this are all constant. When you go to the higher level, you see that sometimes this is not constant. We attach some values to it and it's not constant. So that's what we are looking at right now. Okay, so now since now we are assuming that this is equal to 0 and it is the homogeneous aspect, then now let me show you how to solve it. So now what we are going to do is we are going to assume a solution. That's what you are going to use to solve. So we assume a solution of the form y is equal to e to the power mx. So this is the solution that we are going to assume. So if we assume that y is equal to this, then what we need is we need y prime and we need y prime prime because we have y to be this, which is equal to this. So knowing y will help us to find this and that. So let's do that. What is going to be y prime? Now we know how to differentiate an exponential function, right? Differentiate the top, right? Differentiate the top here. When I differentiate mx, I'm going to have m, then I multiply by the whole function, this. So that's how we differentiate an exponential function, mx. Then I need y prime prime. So I need to differentiate this one again. So this is a constant. So what I'm going to do is I maintain the m and then differentiate this and also get m e to the power mx, which is going to give us m squared e mx. And one thing that you need to know is these things that we've written here is kind of constant, right? Let me just write it better for you to see. So y is equal to mx, y prime is equal to me mx, and y prime prime is equal to m squared. This is kind of constant. Anytime you are solving homogeneous differential equation, you are going to do this. You are going to let y to be this, and your y prime will be this, and your y prime prime 2 is going to be what? This. And then after you are done, what we just need to do is, since we know y prime and y prime prime, we just need to do direct substitution into this. So let's do that. We are going to have m squared a m squared e to the power mx plus b m e to the power mx plus e to the power mx is equal to 0. So what did I do? I'm just putting the y prime prime in place of the y prime prime here. So it's going to be a y prime prime, and then b y prime, and then c. Okay, so this one should be c here. There should be c there, yeah. So then cy. So the y is this. So what can we do here? We can see that we have this running through, so we can factor it out, right? So we can write this one as e to the power mx, and then we are going to have a m squared plus b m plus c is equal to 0. But one thing that we know is, now if we assume that this exponential function is not equal to 0, so that's what we are basically want to do. We want to assume that e to the power mx is not 0. So if we are assuming that this is not equal to 0, then the only function that will make sure that the left hand side is equal to 0 is when this is equal to 0. I mean the one in the parenthesis is equal to 0. So it means that we are going to take a m squared plus b m plus c to be equal to 0. And we can see that this is kind of a quadratic function, right? This is a quadratic function. So what I'm going to do is, this quadratic function that I have here, I'm going to set it to be equal to, let's say, p of m. So let me call this one p of m, which is equal to m x squared plus b m plus c. And I'm going to call this characteristic polynomial. So in session A or objectives, they can ask you to find characteristics polynomial. This is what we are talking about. Good. So this is the characteristics polynomial, right? And then if I have this one to be the characteristics polynomial, that is when I set this one to 0. So now when I set the polynomial to 0, as I said, the only way to make sure that the function is equal to 0 is when this one is equal to 0. And this one also has a name. We call it the characteristics equation. So this is also the characteristics equation. This is the characteristics equation. Good. So this is what we have. So these two are very, very important. Keep it in mind. Characteristics polynomial and a characteristics equation. They are very, very important, right? And then the last one that I'm going to do is, since this is a quadratic, then we are going to have how many roots? We are going to have 2 roots, right? So when we solve for m, so the solution, so let's assume that the solution for m, since it's quadratic, we are going to have m1, m2. I mean, we are going to have 2 roots, and this that is here, this 2 that I've used red to circle, we call it the characteristics roots. So put them in mind, have them in mind. This one is the characteristics root. So this is the characteristics equation, this is the characteristics polynomial, and this is the characteristics root. So we've learned 3 things here. Good. We've learned 3 things here. So now that we know the process of getting the characteristics polynomial, characteristics equation, and root, now let's talk about this. Let's talk about this. Now that we have this, let me just say something here. You see that this is a quadratic function, right? So if it's a quadratic, then my m, as I'm looking for m1 and m2, is basically m is equal to the quadratic function, because the coefficient is a, b, and c. So this is minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So what I need to do is, now I can get the general solution. Remember, we are trying to get the general solution. I can get the general solution based on how this is going to behave. So if b squared minus 4ac is equal to 0, something will happen. If b squared minus 4ac, when I solve it and is greater than 0, something will happen. And then when b squared minus 4ac is also less than 0, something will happen. So these are three methods that we are going to analyze in the next slide. We are going to analyze this and see, okay, if I solve it and I have something like this, what should be the trial solution? What should be the solution for that? So now let's see what we can do here. So as we just derive from there, this is the characteristics equation. This that here is the characteristics equation. And then from the characteristics equation, we're able to find that, okay, we can find m using the quadratic formula, right? So we are saying that this determines the general solution, right? So now what we are going to do is we are going to pick b squared minus 4ac, which is under the root, and we set it to d. And as I said, we are going to consider the first method when this is greater than 0. Now, when this is greater than 0, what happens to the equation? What will be our general solution? So that is how it is. So we solve it, and then this is greater than 0. Then we are going to have two real and distinct roots. So anytime we solve and this is greater than 0, something like 2, 4 in here, then we are going to have two distinct roots, m1 and m2. And as soon as we have something like this, then this will be the general solution. So these are the things that you need to keep it in mind. So y will be equal to c1 e to the power m1x plus c2 e to the power m2x. So this will be the general solution whenever this is greater than 0. You don't need to keep this one in mind. What you need to keep in mind is, anytime we are solving, we take examples. Anytime we are solving, we look at the real aspect. If we are getting two distinct, when you say distinct, it means that m1 and m2 are not the same. I mean, let's say m1 is equal to 2 and m2 is equal to 3. These are two distinct roots and they are real. That is the key words here, real and distinct. So if we have something like this, then this is how we are going to write the solution. So this is, if m was this could have been y is equal to c1 e to the power 2x plus c2 e to the power 3x. So this will be the general solution because it's involved with what? Constant. We have constant. Good. Now let's look at the other method. Now let's assume that we solve and then the discriminant is not greater than 0 but is equal to 0. Then we are saying that as soon as this one is equal to 0, then the characteristics polynomial will be equal to 0 and is going to have what? Or has equal roots. It means that m1 will be the same as what? M2. And this is how we are going to consider our general solution. So as soon as we have this one, this is going to give us, so look at what I'm going to write. Y is equal to c1 e to the power, since they are all the same, I can choose one of them, x1 plus, but look at this, if I write c1 e to the power m2x, now since m1 is the same as m2, you will see that I can write this one out too as m1, and we will see that this is basically the same as this. So we are saying that anytime the equation has equal roots, this is what we just need to do. We need to multiply one of the equation by x so that we can distinguish between them. So this is the same as this, but the only thing that is changing here is we are multiplying this equation by what? X. the proof is there, but I'm not going to go through the proof. But this is what basically you need to remember anytime I have equal root. So for example, if I have m1 to be 2 and m2 to be 2, then my general solution will be c1 e to the power 2x plus c2x e to the power 2x. So this is what I'm going to do. And sometimes you can factor this one out and you have c1 plus c2x, something like this. So we will take example and you understand it better. Good. So that is method 2. Let's look at method 3. So method 3 is basically we are looking at the idea that the one under the root is less than 0. And we know that anytime something is less than 0, we are going to have what? Complex numbers, or let me say complex values. So anytime it is this one, this is what you are going to have. Now this one I'll prove it. I'll write down the solution, but when I finish, I'll try and prove it. So anytime I have a complex and my solution is of the form m is equal to u plus or minus vn I, somebody can write it alpha plus or minus beta I, any of them works, then my general solution is going to be, let me say, e to the power ux. So this is the u and then the x, and then I'm going to have k1, which is the constant, cos of vn x. So this is the vn that I'm writing here, the coefficient of the I, that is the imaginary part, plus k2 sine vn x. So always the angle here is also the same as the angle here. So this is the general solution when the function are distinct but complex, right? So we see that these are distinct. The u is different from the vn, or m1 is different from m2, but they are complex. This is how we need to write the solution. So for example, if I have m to be equal to, let's say, minus 1 plus or minus 2i, then my y will be equal to e to the power minus x, open bracket, or the square bracket, k1 cos of 2x plus k2 sine 2x. Very simple. So second order homogeneous is very, very simple. All you just need to do is how you'll be able to find your m1 and m2. And remember these three methods that we've learned: this guy here, and then this guy here. So this is the end of the video, but I'm going to prove this, how we got this, and then we just end this video. So this is the idea that we were doing. So we said this is what? Distinct, right? So since it's distinct, then we can think about the first formula that we wrote, because this one too was distinct. So we can think about this guy here. So that's what we want to do. So since it's distinct, then we can assume that the solution should be c1 e to the power mx m1x plus c2 e to the power m2x. Right. Now what we need to do now, since we've gotten m to be equal to this, which is plus or minus, it means that we have two roots there. We have, let's assume that m1 is equal to u plus iv, right? And m2 is equal to u minus iv. Then let's do substitution. Our y will be equal to c1 e to the power u plus iv x plus c2 e to the power u minus iv x. So let me try and expand and see the magic, what is happening here. So this is c1 e to the power, the top, I can split the top and write it as ux plus I vin x plus c2 e to the power ux minus I vin x. Using indices, this is the same as c1 e to the power ux times I vin x, right? Plus c2 e to the power ux e to the power minus I vin x. Then I can see that this guy and this guy is the same thing. So I can factor it out and have e to the power ux in bracket C1 e to the power I vin x plus C2 e to the power minus I vin x. So you can see that we are almost there. We have gotten the first term here, this one. So it's left, we bring in the cos and then the sine. Now, you using Euler's formula, right? Complex. So we know that using the Euler's formula, we know that e to the power ix is basically equal to cos x plus sine I sine what? X, right? And we also know that when it is minus, when this is minus like this is the same as cos minus x plus I minus x. But we know that cos is uneven. So when it has the minus, it just go away. So this is the same as cos s. And then sine is odd. So for us to make this one positive, we need to bring out the minus. And then we have something like this. So we are going to use the same idea for this. So here our x is now vin x. And here our minus x is now minus vin x. So it means that the one in the square bracket, we are going to have something like this. Let me open it here. U vin C1, and this is going to be, let me say, what are we going to get here? So this is going to give us cos vin x plus sine. Yeah, so this one should be I. Good. I vin x. Let me close the bracket, plus C1 C2 cos minus vin x plus I sine minus vin x. Good. So this is what we are going to get. Let's just expand it. We are done. So this is going to give us something like this. This is going to give us e to the power this. Now when I multiply x1, I'm going to have c1 cos vin x plus IC1 sine vin x plus C2 cos. This is the same as vin x as we just saw, and this one is going to give us minus I C1 C2 sine vin x. Good. So this is what you are going to get. So now what we can do is we can combine this guy right here to this guy, right? So we are going to have something like e to the power this C1 plus. So let me just, so this and this are the same. So I'm going to factor cos vin x out. So I'm going to have something like C1 plus C2 times cos vin x. Do you agree? I factored this and this out, so it will be left with C1 plus C2. Then plus this one, I'll factor minus sine vin x out. No, I vin x and then I vin and sine vin x out. So this is going to give us I out. Then it's going to be C1 minus C2 sine vin x. So this is what you are going to get. And guess what is happening here? Now this is what we are going to do. We are going to assume that we know that 2 plus 2 is 4, right? 2 is a constant. 2 here is also constant. When I add them, I get a constant. So we are assuming that when I add C1 to C2, I'm going to get a constant. So this is going to give us Ux. So let me name it K1 cos of vin x. Then plus. Now the same thing. This is a constant. This is a constant. So when I add it, I'm going to get a constant in addition with the I. So this is going to give us K2 sine vin x. So here C1 plus C2 is equal to K1. Then I C1 minus C2 is equal to K2. And this is the general solution for when the function is complex. But what we just need to know is we just need to learn this here, and then we are done. So in the next video, this is what you are going to do. In the next video, I'm going to take examples on method 1. So I just want you guys to understand. So in the next video, I'm going to take examples on method 1, how to solve method 1 with different questions, right? Like 5 of them. Then I'll give you trial question. The next video again, we go to method 2. In the next video again, we go to method 3, in that order. All right. So see you in the next video.